Hello, in this video I'm going to show you how to use the Poisson distribution to calculate probabilities. So in this case the question states manufacturer estimates that 0.25% of his components are defective. It's very similar to the previous one. The previous components are packed in packets of 200 components, and it's asking us to find the probability of a packet containing less than 3 defective. So as we did with the binomial distribution, the first thing is identifying the values that are given to us. So 0.25 is P. That's 0.25%, which means it's 0.0025. Then we also find N is 200. Because it's greater than 10, instead of using the binomial distribution, we're going to use Poisson distribution. Remember, N is the value that is going to tell you which one to use. The formula for Poisson's distribution is this one. We have e to the power of minus the mean to multiply by the mean to the power of r over r factorial. So we need to calculate the mean, and it's the product of n multiplied by p. In this case 0.5. Now the probability of a packet containing less than 3 defective, so R is 3, but we're looking for less than 3, so we're going to have to calculate the probability of x being less, strictly less than 3. It's going to be equal to the probability of x being 0 plus the probability of x being 1 plus the probability of x being 2. And each of these three terms will be calculated using the formula for Poisson's distribution. The probability of x being 0 defective, is going to be e to the power of minus 0.5 multiplied by 0.5 to the power of 0, which is 1, and 0 factorial, which is 1. Then the probability of x being 1 is going to be e to the power of minus 0.5 multiplied by 0.5 to the power of 1 and divided by 1 factorial, and the probability of x being equal to 2, similarly e to the power of minus 0.5 squared divided by 2 factorial. We add those three values. So those three values are 0.6065 plus 0.30326 plus 0.0758. If we add them all up, I'm going to continue up here, the probability of x being less than 3 will be equal to 0.9851. And that's how you use Poisson's distribution.